to review solving power functions, and we'll also review simplifying exponents in the warm-up. So for the warm-up, simplify and solve for x if needed. So with the first one, over here, 20x to the 7th over 25x to the 9th. Let's simplify this. Start with your numbers first and think, all right, how can I reduce 20 over 25? Well, you can divide each of those numbers by 5 and you'll get 4/5. Now think I have 7 x's on top and 9 on the bottom. So when I cancel, how many are left and where? And there would be 2 left on the bottom. So here is the first one simplified. The next one right here, we're solving for x. Let's try finding a common base, but we could also solve using a log, but I'm going to do using a common base. So I know 3 is a common base. 9 is the same as 3 squared, and then we have our 5x, so times 5x, and that equals 3 to the 20th. Now that my bases are the same, I'm going to just set my exponents equal. 2 times 5x is 10x. We got 10x equals 20. And we can divide each side by 10, and we get x equals 2. Okay, so there is another way to solve using logs. So I'll show you that with this one as well. Common base first. So using a common base, I'm actually going to take a screenshot of this and show you 2 ways to solve 3. So the first way is finding a common base. I know that 2 and 5 is a common base of 25, and 4 and 2 and 5, but I have to flip one to make a match. So I'm going to keep this one the same. 2/5 to the x equals, I'm going to flip it and change the base. Okay, I'll do it in 2 different steps. So this is 5 squared, and this is 4 squared. And again, I'll rewrite it like this. 2/5 to the x equals 4, I wrote that wrong, didn't I? Okay, so I shouldn't have written 4 squared. I should have written 2 squared as 4. And I'm going to rewrite it this way, 2/5. And it was to the 2nd power, but I flipped them, so this is -2. And now that the bases match, I can cross these out. X is -2. But let's say I didn't want to bother finding a common base. You can use logs. So this is log. The base is 2/5 because it has the exponent of 25 over 4 equals x. And then you can just type this in your calculator and we should get -2. But let's try it. So let me clear Scratchpad. And I will do log base 2/5 of 25 over 4. And we'll get -2. So 2 ways to solve, actually 3 ways. I could use guess and check. When x is the exponent, these are all exponential functions. Or these 2, I should say, are exponential functions. This is a power function. All right, learning objective today, we're going to review the difference between a power function, exponential, and review previous concepts. Okay, so first let's look at exponential functions. The general form of exponential, we have our starting value times our base, which is some number to the x power. And to solve, we can use guess and check, finding a common base, or using a log. So again, I'll review finding a common base one last time, and then we'll use logs because I think those are the easiest. All right, so here we could use guess and check, just plug in until we get 27. 9 to what power is 27? Common base of 9 and 27 is 3. So this is 3 squared to the x power equals, and 27 is 3 to the 3rd power. And once you have a common base, you ignore them, you set your exponents equal, and you solve. So here x is 3/2 or 1.5. Okay, like I said, you could use guess and check, you could find a common base, but logarithms probably the easiest way. So let's use a log to solve the next one. Log, here the base is 27, and then you loop it around, of 1 over 81 equals x. We type it in, log base 27 of 1 over 81. Yep, 1 over 81. Oops. And we get -1 1/3. So x equals -1.3 repeating, or you can say -1 1/3. Okay, so those are exponential functions when x is the exponent. Let's take a look then at power functions. So the general form of a power function is when the base is your variable and the exponent is a number. So what that looks like, y equals, a is our starting value, but here's the x, not in the exponent like an exponential. And then b is some number here. These are power functions. And to solve power functions, you get rid of the number by taking it to the power of the reciprocal. So for example, two ways that we know how to solve this. We can take the square root of each side. And x equals 4, also x equals -4. The way that we learned yesterday is x squared, if we want to get rid of the squared, we can take it to the reciprocal power. So we're going to take it to the power of 1/2 because 2 times 1/2 is 1. And we could do 16 to the 1/2, and we would also get 4. And we know that also it would be -4. Let's try the next one, n to the 3rd power. How do we get rid of something to the 3rd power? We're going to take it to the 1/3 power. What we do on one side, do it on the other side. Let's type that in our calculator, 125 to the power of 1/3, and we get 5. So here x, or n, equals 5. All right, for this one, before we take it to the 1/4 power, we're going to divide by 2. So we have 1250 divided by 2. And then we're going to take that to the power of 1/4, so we should write our work here. n to the 4th equals 625. To get rid of the 4th power, we take it to the 1/4 power. And we'll do that here. We get 5. So here answer M is 5. All right, the next one, we have a bunch of things to get rid of the -6 and the -2. First step, add 6 to each side. So we get -2x squared equals let's do -104 plus 6. Okay, -98. Oops, I put 96. All right, now we're going to divide each side by -2. We get x squared equals 49. And again, we can square root it, or we can take it to the 1/2 power. Either way, we get x equals 7. Also, x equals -7. All right, last one. Whoops, for number 5. We have to get rid of the 6 first, so let's take our 90. Let's divide by 6. Okay, so let's take a look at that. 90 divided by 6. We get 15. All right, so x to the 2.5 power equals 15. And then to get rid of the 2.5, we take it to the power of the reciprocal. So we have 15 to the power of 1 over 2.5. Whoops. And we get about 2.95. So x is about 2.95. We can check our answer by plugging it in for x right here and making sure we get 90. So let's try that. Let's do 6 times x, which is our answer, to the power of 2.5. And we get 90. So to summarize, with exponential functions, the variable is located in the exponent, and you can use logs to solve. And with power functions, the variable is located in the base, and you can get rid of an exponent by using the taking it to the power of the reciprocal. Okay, last thing that we're going to review is radical to exponent form. Here's what it looks like. This would be x to the 3/4 power. If there's not a number outside a radical, there's an invisible 2 there. So this is x to the 5/2. To go backwards, the number on the bottom goes on the outside. And so here, the number on the bottom is 9. Okay. All right, so your assignment, you're going to practice exponentials. You're going to practice power functions and solving each type.